The autoflight system, AFS, on the A320 family is designed for assisting the pilot in flying the aircraft within the normal flight envelope, hence enhancing safety and optimizing performance. This module is an introduction to the AFS. Let's begin by building up a basic conceptual diagram. The AFS could be represented as 4 main sections. At the heart of the system is a computation and processing section, the brain. The central processing section has access to several information sources. The pilots have access to the central processing section via input devices. Finally, after computation and processing, commands are provided to output devices. For the AFS in the A320 family, computation and processing are done by 2 Flight Management Guidance Computers, FMGC. The 2 FMGCs are identical and normally work together, so for training purposes we will group them as the Flight Management Guidance System, FMGS. The FMGS receives navigation information, which contains details of airfields, nav aids, airways, routes, waypoints, procedures, SIDS, stars, approaches, missed approaches, etc. Aircraft performance information, the Air Data and Inertial Reference System, ADIRS, and the Global Positioning System, GPS, for position and dynamic information. You will learn about them in the navigation chapter. The clock, radio navigation information. Pilots provide inputs to the FMGS using 2 multipurpose control and display units, MCDU, for long-term interventions, and a single flight control unit, FCU, for short-term interventions. The FMGS provide outputs to the flight directors, FDs, and autopilots, APs, for pitch, roll and yaw control, the autothrust, ATHR, for thrust control, the MCDUs and EFIS for the display of information, and the navigation radios for the automatic tuning of radio aids. The FMGS is divided into 3 main parts: flight management, flight guidance, flight augmentation. The flight management part of the FMGS controls the following functions: navigation, the position of the aircraft and the estimated accuracy of this position; flight planning, the flight plan computation; performance optimization, costs, speeds and altitude optimization; predictions, the accurate estimates for waypoints, altitudes, speeds, fuel, destinations and alternates; display management, the control of information to the EFIS system to display auto flight modes and navigation information. The flight guidance part of the FMGS provides autopilot commands to automatically control pitch, roll and yaw, auto thrust commands to automatically control thrust, flight director commands for the pilot to control the pitch, roll and yaw. The flight augmentation FAC part of the FMGS provides flight envelope computations, minimum speed such as VIs or maximum speed such as VMO or VFE, maneuvering speed computation for example, best speed to fly in a given flap configuration, wind shear detection, which triggers the wind shear warning, angle of attack protection, alpha floor protection, triggered when the aircraft angle of attack is above a predetermined threshold. Note, the FAC has various yaw functions, such as yaw damping, turn coordination, and others which will be reviewed in the flight control chapter. As a general rule, the two FMGCs have access to information provided by on-site sensors, except for certain parameters or in case of failures. They exchange information for validity comparison purposes. For example, information from MCDU-1 is received by FMGC-1 and transmitted to FMGC-2. All FMGCs and MCDUs are then synchronized. The inputs from the FCU are fed to both FMGCs. Both FMGCs send their commands to the FDs, the autopilots, and the autothrust system. According to a given internal logic, one FMGC is declared master. E.g., if autopilot 1 is on, FMGC 1 is master. Amongst other things, this determines which autothrust channel is operative. The controls and indicators found in the cockpit are: 1 Flight Control Unit, or FCU, 2 Flight Director push-button switches located on the EFIS control panels and the associated EFIS displays, 2 Multipurpose Control and Display Units, MCDU, 2 thrust levers, mainly in interface with autothrust. You have just reviewed the overall presentation of the autoflight system. In the next modules, we will review each component in more detail. The Flight Control Unit, or FCU, is the short-term actions interface with the FMGS. It is used to arm or engage the guidance modes and to select their associated targets. It is also used to set the autopilots, APs, and/or autothrust, ATHR, on. The FCU has 2 channels. Each channel is able to drive the entire FCU. For the rest of this module, we will concentrate on the center part of the FCU. The FCU enables you to select targets and arm engage their associated modes. For speed Mach, for lateral guidance, e.g. heading, and for vertical guidance, e.g. vertical speed. It enables you also to set the autopilots and autothrust to on. We can find in the control areas 4 selector knobs and their associated windows, as well as 3 mode engagement push buttons. As a general rule, if you turn a selector knob, you select a guidance target. If you then pull the same knob, you engage a mode which will guide the aircraft to the selected target. Such a mode is a selected mode. The selected target is clearly displayed on the associated window and on the associated PFD scale using a blue target symbol. On the other hand, if you push a selector knob, you arm or engage a mode, which will guide the aircraft to a target managed by the FMGS. Such a mode is a managed mode. In this case, the associated window, except the altitude one, displays dashes with a white dot. Let's now have a closer look at the Speed Mach section. The Speed Mach selector knob enables you to select the target speed for the autopilot or autothrust. This selection is done by turning the selector knob. The corresponding speed is then displayed on the window. By pulling the speed knob, you engage the selected speed mode for the autopilot and/or autothrust, which will guide the aircraft to the selected speed target. By pushing the speed knob, you engage the managed speed mode for autopilot and/or autothrust. This will guide the aircraft to the managed speed target profile as computed by the FM. The speed window displays, in this case, dashes as well as an illuminated white managed speed Mach dot. The selection in the speed window can either be a speed or a Mach. In normal operation, the change from speed to Mach target occurs automatically in climb at around flight level 300 and vice versa in descent. However, you can toggle the selected target between speed and Mach by pushing the Speed Mach push button on the FCU at any time. The current selection is clearly indicated by a speed or Mach legend on the display. That is all for the Speed Mach area. Let's now learn more about the lateral area. Like the speed selector, the heading track can be turned, pulled, or pushed. By turning it, you select a heading or track target. We will see later on how to toggle between heading and track. By pulling it, you engage the selected heading or track mode for the autopilot flight director. By pushing it, you engage the managed navigation mode for the autopilot flight director, which will guide the aircraft along the active leg of the primary flight plan. In this case, the window displays dashes as well as an illuminated white managed lateral dot. The heading, vertical speed, track, flight path angle push button is used for the display of flight path vector, FPV, or bird on or off the PFD. When the bird is on, your flight reference is the flight path vector, the aircraft trajectory. When the bird is off, your flight reference is the attitude of the aircraft. The consequence for the autopilot flight director is that you change their basic guidance references from track, flight path angle, bird on, to heading, vertical speed, bird off. Flight reference selected here is attitude, bird off. The aircraft attitude symbol is your flight reference, and if the flight director is on, the flight director crossbars are displayed. The selection is also indicated by heading vertical speed legends on the FCU display. Change the reference. The selected flight reference is now the flight path vector, bird on. The bird symbol is your flight reference and materializes the aircraft current trajectory. If the flight director is on, the Flight Director Flight Path Director FPD is displayed. The selection is now indicated by track flight path angle legends on the FCU display. The vertical area is divided into two parts. The first one relates to altitude. The second one relates to vertical speed or flight path angle guidance modes. The altitude window is never dashed. It always displays the target altitude, which is systematically selected by the crew as the next applicable clearance altitude. As for the other knobs, this knob can also be pulled or pushed. By pulling it, you engage a selected vertical mode, which will guide the aircraft towards the FCU selected target altitude while disregarding any altitude constraints of the vertical flight plan. By pushing it, you engage a managed vertical mode which will guide the aircraft towards the FCU selected target altitude, matching all altitude constraints of the vertical flight plan and along the pre-computed descent path. The white level change light illuminates. This knob is actually two different selectors. The inner selector sets the altitude target in the window, and an outer ring changes the altitude increments. The increment-decrement of the altitude can have two settings, 100 feet or 1,000 feet. The metric altitude push button is also part of the altitude area. It has been already seen in the EIS chapter. We just remind you that this push button is used to display the selected altitude, written in meters, on the permanent data display area at the bottom of the ECAM system display, SD. Let's now have a look at the vertical speed flight path angle part. Here again, the vertical speed flight path angle selector knob has three functions. The first two are similar to what we've already seen. The turn function enables you to select a target vertical speed or flight path angle. The pull function enables you to engage the selected vertical speed or flight path angle mode. The third function, push, differs from the other push functions. In fact, when you push the selector knob, the FM commands an immediate level off. Vertical speed or flight path angle equals 0. The value 0 is then displayed in the window as well as on the FMA. To set a value, let's first turn the vertical speed flight path angle selector knob. Turn the vertical speed flight path angle selector knob. As soon as the vertical speed flight path angle selector knob is turned, the vertical speed flight path angle window indicates the current flight path angle or vertical speed. In this case, a flight path angle value is displayed. Notice how the degrees are displayed. The minus sign indicates a descent. A climb would be indicated by a plus sign. To engage the autopilot flight director flight path angle selected mode, we have pulled the selector knob for you. For training purposes, we wish to change the flight reference and thus select the bird off, changing the basic autopilot flight director guidance references from flight path angle to vertical speed. Switch back to heading vertical speed. The vertical speed window is now showing a vertical speed target, minus 800 feet per minute, synchronized with the current vertical speed. Notice how the vertical speed is displayed and the change of labels from flight path angle to vertical speed. Vertical speed flight path angle window can also display dashes if a vertical managed mode is engaged. This case will be seen and explained later in the course. Let's now take a brief look at the other push buttons located on the FCU. The lock push button arms engages the lock mode, in case the aircraft is cleared to intercept the localizer only, or in case of localizer only approach. When lock mode is armed engaged, the green lights on the push button are illuminated. You will see this function in more detail during your free play and simulator sessions. The approach push button enables you to arm engage the approach modes, depending upon the approach type selected in the FM's flight plan. When engaged, green lights are illuminated on the push button. The XPED push button allows you to temporarily expedite the climb or descent towards the altitude selected on the FCU. The target speed is then automatically set to the best climb or descent speed in order to achieve that goal. When selected, green lights are illuminated on the push button. Autopilot 1, Autopilot 2 push buttons set Autopilot 1 and or Autopilot 2 to on. The Autothrust push button sets Autothrust to on. The push button illuminates green when autothrust is on or when it is armed. See autothrust logic, e.g. as soon as takeoff power is applied. We will come back to these controls in a later module. Note, these push buttons may also be used for APs and or autothrust setting to off, but in normal operation this is not the recommended disconnection procedure. You have now seen an overview of the FCU. The FCU is basically a selector panel with various functions. Remember that one of our golden rules is know your FMA at all times, which means that any new selection made on the FCU should be confirmed on the FMA located on the PFD. Term actions through the MCDU and short-term actions through the FCU must be cross-checked on the Flight Mode Annunciator, FMA, located at the top of the PFD, as well as on the various scales of the PFD. The Guidance Mode Engagement ARM status and their associated guidance targets are provided on the FMA and PFD scales: speed, heading, altitude. When managed by the FMGS, the targets and modes are displayed on the FMA as the flight progresses. Let's discuss the FMA in more detail. As you can see, the FMA is divided into 5 columns. The first column is dedicated to thrust. This is where the autothrust modes appear. The second one displays the vertical modes of the autopilot and flight directors. The third one, the lateral modes of the autopilot and flight directors. The fourth one gives the approach capability of the autoflight system and the DH or MDA. The last column displays the engagement status of the autopilots, flight directors and autothrust systems. In certain cases, the second and third columns are combined to display a single autopilot flight director mode, which is common laterally and vertically. These modes are common modes for approach, which means that they are closely linked together. You will study all the modes in later modules. The FMA can display 3 lines in each column. Let's look at the first 3 columns. The first line shows the engaged modes to the flight guidance system. In our example, the speed mode is engaged for the autothrust. This means that the autothrust will manage the thrust to track the target speed. The altitude, ALT mode, is engaged for the vertical mode. This means the autopilot FDs will provide guidance to maintain altitude. The heading, HDG mode, is engaged for the lateral mode. This means the autopilot FDs will provide guidance to the selected heading. Note: the color coding will be explained later when the concept of managed guidance and selected guidance will be discussed. The second line shows armed modes for the flight guidance system. In the example shown, GS and LOC in blue indicate that glide slope and localizer capture modes are armed. The third line shows reminders or messages. In our example, check approach cell advises us to check the consistency of selected approach. Note: some messages are spread over 2 columns. When any mode changes on the FMA, it is boxed for a few seconds to draw the pilot's attention to this new status. In our example, the aircraft is intercepting the localizer. The star after the lock indication means that the aircraft is in the capture phase. Once established on the localizer, the indication becomes lock. Notice that the glide slope is still armed. We will be learning more and more about the FMA in the following modules, as we are constantly using it during all autoflight operations. This module, we will review how to turn the autopilots and/or the FDs on. First, let us review how to engage the autopilot. Autopilot on. You are the captain and pilot flying. The autopilot is an assistance to the pilot to fly the aircraft. The autopilot works within the aircraft normal flight envelope. Therefore, the pilot can turn it on whenever the aircraft is within this flight envelope. Here, we are just airborne, above 100 feet from the ground. Engage autopilot 1. The FMA confirms the engagement of autopilot 1. As a general rule, when the captain is pilot flying, autopilot 1 is used. When the first officer is pilot flying, autopilot 2 is used. This ensures that each autopilot will be alternatively operated. The autopilot can be used just after liftoff from, say, 100 feet until the end of the landing rollout. In most cases, only one autopilot can be engaged at a time. However, in case of an ILS automatic approach, both autopilots may be turned on at the same time. This ensures the best level of redundancy required to safely achieve auto-lands, auto-rollouts, or low-altitude go-arounds. As a consequence, once cleared for an ILS approach, the pilot presses the approach push button to arm lock and GS modes. The second autopilot may then be turned on. Engage autopilot 2. The FMA confirms the engagement status of both autopilots, as well as the resulting level of redundancy achieved, dual. This will dictate the minimum possible DH. You will see this in more detail in the guidance mode modules. Now let us review how to disconnect or turn the autopilot off. You are now flying an automatic approach. When in sight of the runway, you decide to take over manually. To turn the autopilot off, you press the red Autopilot Disconnect push button, also known as Takeover push button, located on either side stick. When the weather is fine, you are number 1 for approach. Disconnect the autopilot. Turning an autopilot off via the Takeover push button triggers the following temporary warnings. A single cavalry charge oral warning, the master warning flashing several seconds, and an autopilot off red message on the right column of the engine warning display several seconds. By pressing the Takeover push button again, you will cancel all these warnings immediately. Notice that, on the FCU, the autopilot's lights are extinguished. On the FMA, autopilot 1 plus 2 is no longer displayed. The approach capability is downgraded to Cat 1, and on the ECAM system, all warnings are now off. The recommended technique to set autopilots off is to press the Autopilot Disconnect push button on a side stick. They can also be set to off by acting on the side stick or rudder pedals with a force beyond the given threshold, or pressing an autopilot push button on the FCU when the corresponding autopilot is on. These last two actions lead to a repetitive cavalry charge, a permanent activation of the master warning, and a permanent red autopilot off warning on the left column of the engine warning display. This is considered by the FG as an involuntary autopilot disconnection. The FG also drives the Flight Director FD symbols displayed on either PFD. The Flight Director is an assistance provided to the pilots to accurately hand-fly the aircraft along a given segment of a trajectory. The Flight Director provides guidance orders to the pilots as a function of the guidance modes and targets selected on the FCU. These orders are materialized by specific symbols, e.g. crossbars. The flight director symbols are displayed on either PFD. The symbols on PFD1 are driven by FG1. Those on PFD2 are driven by FG2. The engagement status of the flight director is indicated on the FMA. Here the flight director symbols are called crossbars and are referenced to the aircraft attitude symbol. To turn the flight director on or off, use the flight director push button located on either EFIS control panel. When a flight director is on, the green bars of the corresponding push button are illuminated. Here both FDs are on. Let's turn them off. Each pilot presses his flight director push button. Flight director bars are removed from the PFD. Flight director engagement status is cleared on the FMA. Flight director push button green lights are extinguished. Note that we have switched the autopilot 1 off for you. When both autopilots and FDs are off, note that all mode fields, except the one of the autothrust, here Mach, are blank on the FMA. It is important to notice that if both FDs are set to off while autopilots are off, autothrust, if active, is automatically in speed mode or Mach mode. Let's now turn the FDs back on. Suppose that the captain presses his flight director push button first, and then the first officer. Flight director 1 is on. The crossbars are displayed on PFD1. The FMA on both PFDs indicates 1 flight director as flight director engagement status, meaning that only flight director 1 is on. The flight director 1 associated modes. Notice that flight director 1 push button illuminates in green on the EFIS control panel. Let us now turn the first officer's flight director back on. Note, when both autopilots and FDs are off, and you turn one of them back on again, it comes up in basic modes: vertical speed heading or flight path angle track. Both FDs are now on. The crossbars are displayed on PFD2. Both FMAs indicate 1 Flight Director 2 as Flight Director engagement status, meaning that both FDs are on. The on-side Flight Director guidance modes. Note that Flight Director 2 push button illuminates in green on the EFIS control panel. As a general rule, it is strongly recommended to set both FDs on or off at the same time. Let's review the flight director symbols. The flight director crossbars consist of 2 independent bars referenced to the aircraft attitude symbol. A horizontal bar indicating the pitch command, a vertical bar indicating the roll command. The roll bar is replaced by a yaw bar index for takeoff and landing rollout purposes from an ILS-equipped runway. The yaw bar assists the pilot to properly track the localizer on ground while in low visibility condition. The principle of the Flight Director crossbars has been reviewed in the EFIS module. Let's review another Flight Director symbology. We have seen the Flight Director crossbar symbology referenced to the aircraft attitude symbol. The other Flight Director symbology is referenced to the Flight Path Vector, FPV, or bird. The bird can be displayed on/off on the PFD by pressing the Heading, Vertical Speed, Track, Flight Path Angle push button on the FCU. Click on the Heading, Vertical Speed, Track, Flight Path Angle push button. Notice that on the PFD, the bird is now displayed. On the FCU, the indications have been modified to reflect the change to Track, Flight Path Angle. Let's have a closer look at the PFD. The Flight Path Vector, FPV, is displayed. The crossbars are removed and replaced by the Flight Path Director, FPD, referenced to the Flight Path Vector. In case Flight Director bars are displayed and the guidance modes are vertical speed and/or heading, these modes are automatically changed to Track, Flight Path Angle if you select the bird on. Have a look while we do this for you. First, check that Flight Path Vector is displayed. You can see that the mode changes are outlined on the FMA with white boxes. Notice also that the heading target has been changed to a properly synchronized track target. Let's see an example of a manual track change. We will concentrate on the PFD. When flying manually, the objective is to center and align the flight path vector on the FPD. We will turn onto a track of 140. The FPD commands a roll to turn onto the selected track. The aircraft is rolled until the flight path vector and FPD are aligned. Approaching track 140, the FPD demands a roll to level the wings. When in track flight path angle, the FPD reverts to flight director bars in case of go-around. You will practice the use of the flight path vector and the FPD and the simulator. We will now look at how the flight guidance achieves its automatic thrust control function, the auto thrust system or auto thrust. The auto thrust can work in two different modes. Speed mode. The auto thrust continuously adjusts the thrust in order to maintain a target speed or Mach, e.g. during cruise or approach. Thrust mode. The auto thrust sets a given thrust, e.g. max climb or idle. The auto thrust modes are automatically linked to autopilot flight director vertical modes. When autopilot flight director vertical mode controls a trajectory, e.g. altitude hold, vertical speed, glide slope, the autothrust is in speed mode. When Autopilot Flight Director Vertical Mode adjusts the aircraft pitch in order to keep a target speed or Mach, e.g. climb, descent, the autothrust is in thrust mode. The main autothrust controls available for the pilots are the thrust levers. On the Airbus fly-by-wire family, the autothrust does not back-drive the thrust levers while it adjusts the thrust. Let's have a closer look at them. When the autothrust is off, the crew controls the thrust as usual by moving the thrust levers over a quadrant. For forward thrust, this quadrant carries 4 physical detents or stops, which are idle, climb for max climb thrust, flex MCT for flex thrust at takeoff or max continuous thrust, toga for max takeoff or go-around thrust. The autothrust can only work when the thrust levers are set forward of the idle detent and up to the climb detent, or MCT detent in case of engine failure. If the thrust levers are set by the pilot in the reverse position, the autothrust cannot operate. Note, the alpha floor function is an exception which will be covered later on. When autothrust is on, the thrust lever position determines the maximum thrust which can be commanded by the autothrust, for example, to accelerate in speed mode. On the thrust gauge, which we will be talking about in the engine chapter, the thrust lever position is indicated by a symbol. It materializes the maximum thrust available for the autothrust in a normal operation. The autothrust has 3 states. It can be either disconnected or off, armed, ready to be set to on by a specific pilot action on the thrust levers, active or on. Let's see these states in more detail. We are taxiing to the runway. Because we are on the ground, the autothrust is necessarily disconnected. This is confirmed by the absence of any autothrust-related indications on the FMA and by the extinguished autothrust push button on the FCU. Thrust is manually adjusted by the crew as required to taxi the aircraft. You are cleared for takeoff. The pilot flying must manually set the thrust levers to flex or toga to initiate the takeoff roll. Click on the thrust levers to initiate the takeoff roll. As soon as the thrust levers are set in the toga position, the FMA shows autothrust blue, indicating that autothrust is armed, manual toga white, indicating that the pilot manually controls the thrust via the thrust levers set in toga. Note, toga is the maximum thrust available for takeoff. At the same time, on the FCU, the autothrust push-button light illuminates in green. The fact that the autothrust is armed means that it is ready to be engaged by a pilot action on the thrust levers. Note that when the autothrust is armed, the pilot has manual control on the thrust with the thrust levers. Crossing the thrust reduction altitude, thrust red altitude, the pilot must manually set the thrust levers to climb detent. On the FMA, a flashing lever climb prompts the pilot to set the thrust levers back into climb detent. Set climb thrust now. Click on thrust levers to set climb thrust. Notice that on the FMA, autothrust white indicates that the autothrust is on, thrust climb green indicates that the autothrust is in thrust mode. Since the thrust levers are set to climb and the autopilot commands a climb mode, the autothrust commands thrust climb. The white boxes around the modes highlight the fact that a mode change has occurred on the FMA. Note, the autopilot 1 vertical mode adjusts the pitch to maintain the takeoff scheduled target speed. In normal operation, when autothrust is on, the levers are left in the climb detent throughout the flight until the flare. The autothrust adjusts the thrust as required between idle and max climb, but the thrust levers, not being back-driven by the autothrust, remain in the climb detent as set by the pilots. Crossing the acceleration altitude, AC-alt, the FM climb phase is initiated. The autothrust maintains climb thrust, while the vertical mode, climb, adjusts the pitch to accelerate the aircraft towards the new speed target. The initial climb speed here is 250 knots. If at any moment the pilot needs some additional thrust, he will push the thrust levers forward from climb detent. He will then manually control the thrust. In that case, manual thrust is displayed in white on the FMA. Autothrust is displayed in blue, since the autothrust is armed. Whenever the pilot brings the thrust levers back into climb detent, the autothrust is automatically back on in the appropriate mode. Provided the thrust levers are set between idle and climb detent, all engines operating, or in between idle and MCT, one engine inoperative. Beyond these detents, the pilot has manual control on the thrust. When the aircraft reaches the target altitude, Autopilot Flight Director switches to altitude mode. The autothrust switches to speed, Mach mode, as indicated on the FMA. In this mode, the autothrust continuously adjusts the thrust to maintain the target speed, Mach. Autothrust is also in speed mode when Autopilot Flight Director vertical modes are vertical speed or flight path angle, GS, and generally during the approach. We are now in approach, just before flare. You fly the aircraft manually with the autothrust engaged. Note that the autothrust is in speed mode. During a hand-flown flare, the pilot has to reduce the thrust for landing. He will do so by bringing the thrust levers back to idle at about 20 feet. Note, If he does not do so, the autothrust will increase thrust to maintain the speed. A retard auto call-out comes up at about 20 feet as a reminder to retard the thrust levers. Click on the thrust levers to set them to idle. Thrust levers are now set to idle. This turns the autothrust off. Note that on the FMA, the white autothrust indication is no longer displayed. The FMA autothrust column is blank. On the FCU, the autothrust push button is now extinguished. We have just seen how to turn the autothrust off by setting the thrust levers back to idle for landing. The recommended procedure to set the autothrust off in flight in order to avoid any thrust change at autothrust disconnection is 1. To move the thrust levers back so that the thrust lever position symbol roughly matches the present N1 or EPR. 2. To press the instinctive disconnect push button located on the thrust levers. Note: pressing at least one push button for more than 15 seconds will inhibit the autothrust, including alpha floor protection, for the remainder of the flight. When the autothrust is off during flight, in order to turn it on again, press the autothrust push button on the FCU, with the thrust levers in or below climb detent. Note: you can disconnect the autothrust by pressing the autothrust push button on the FCU. This is not the standard recommended procedure. Flight management part of the FMGC performs 4 main functions: navigation, based on accurate position; flight planning; performance prediction and optimization; management of the displays. Accurate position computation is one of the essential functions of the FM part of the FMGC. Each FMGC computes its own aircraft position, FM position, from a mixed IRS position and a computed radio position or a GPS position. The system then selects the most accurate position, considering the estimated accuracy and the integrity of each positioning equipment. IRS position from the 3 IRSs. If one IRS fails, each FMGC uses only one IRS, onside IRS or IRS-3. Each IRS computes a hybrid position that is a mix IRS GPS position called GPIRS. Only one of the 3 GPIRS positions is selected by the system according to its figure of merit and priority logic. If the GPIRS data does not comply with an integrity criteria, the GPS mode is rejected and the radio position updating is used. GPS primary lost is displayed on ND and MCDU scratchpad. Each FMGC uses on-side nav aids to compute its own radio position. The nav aids which are automatically auto-tuned can be DME DME, VOR DME, DME ILS, Lock DME, ILS approach selected, VOR ILS, Lock DME, ILS approach selected. Each FMGC computes a vector from its mix IRS position to the radio or GPS position. This vector is called bias. The bias is updated continuously if radio or GPS position is available. If the radio or GPS position is lost, the bias is memorized and added to the mix IRS position to compute the FM position. Note, at takeoff, the FM position is updated to the runway threshold position memorized in the database. Depending on the navigation mode used by the system, IRS GPS, IRS DME DME, IRS VOR DME, or IRS only, the FMGC computes an estimated position error, EPE. The EPE is then compared to the required navigation performance, RNP, defined by the airworthiness authorities as a nominal error tolerated within a flying area, TMA, or along a given flight plan leg. If the EPE is lower than RNP, accuracy is high. If the EPE is higher than RNP, accuracy is low. When the accuracy switches from high to low, a message nav occur downgrade is displayed on ND and on MCDU scratchpad. When the GPS function is lost, the crew must check the position accuracy using raw data information if available. The position accuracy cross-check using raw data information has to be done periodically during the flight, unless GPS is primary, systematically when GPS primary lost message comes up, systematically when nav occur downgrade message comes up. Keep in mind that high-low messages are computed on estimated data. Therefore, even if low is displayed, the accuracy check may be positive. For flight planning, the pilot inserts the following data into the FMGS via the MCDU. The lateral part of the flight plan, the vertical part of the flight plan, speed, time, altitude constraints or step climb. In fact, two flight plans can be inserted in the FM. A primary one, used for the legs to be flown, and a secondary one, used to prepare an alternative departure or arrival or a diversion, which can be activated by the pilot whenever required. The Flight Management System, or FM, uses two databases to perform its computations, a navigation database and a performance database. The Navigation Database, or NAV database, contains all the necessary information for the lateral flight plan, such as routes, airways, VORs, non-directional beacons, waypoints, and airports. The navigation database is updated every 28 days, and its currency and validity is checked on this page during the pre-flight. Notice there is an active database and a secondary or second database. or the next database. Databases are loaded two at a time, so that if the first one expires away from a maintenance base, the pilot can activate the second one before departure the next day. Warning: never activate the second database in flight, as all current active data would be lost. The Performance Database, or PERF database, contains the aircraft performance model and is used to optimize the flight plan and to obtain predictions such as ETAs, EFOB, etc. The change code, CHG code, allows the engineering team to modify the idle and performance factors in order to take engine aging into account. The lateral flight plan includes departure, en route, arrival, alternate. These elements are defined by waypoints and legs. The FMGC automatically strings the legs in sequence. When flying in navigation mode, navigation managed by the FMGC, the aircraft is guided on a leg called active leg, defined by a from and a to waypoint. The to waypoint is depicted in white on the MCDU and on the ND as well, in the top right-hand corner. During pre-flight, the first thing that we do is confirm the correct information on the status page. We are then ready to begin programming the route of flight. This is called initializing the flight plan. This initialization of the flight plan is done through the init page A. We will call it for you. The pilot enters the flight plan in either of three ways: by inserting an origin-destination pair and then manually selecting a departure, waypoints, airways and an arrival; by inserting a company route name stored in the database; or by sending a request for an active flight plan initialization. See FANS course. The flight plan, once inserted, can be modified by two types of revisions: lateral revisions, which have an immediate effect on the active flight plan; lateral revisions that lead to a temporary flight plan. These revisions are selectable from the left keys on the MCDU. The direct to function is an immediate effect lateral revision, which allows the aircraft to fly from the present position directly to a waypoint, with A-beam points displayed along the track if A-beam PTS is selected, or to intercept an inbound or outbound radial to/from this waypoint. If the waypoint does not belong to the flight plan, it has to be inserted via the scratch pad. Waypoints which can be inserted are waypoints from the database, or waypoints which are defined by the crew: place, bearing, distance; place, bearing, place, bearing. Deleting a waypoint in the flight plan will create a flight plan discontinuity in the active flight plan. Adding a waypoint in the flight plan will create a flight plan discontinuity. Using a lateral revision at origin, the pilot can insert or modify the takeoff runway, the SID, and the en route transition through the departure revision. The en route transitions, trans, are the various possible trajectories defined between the last waypoint of the SID and the first en route waypoint. There are three transitions available in this example. A lateral revision at destination, line select key 6 left, gives access to the arrival data. The runway and the type of the approach can be chosen. As well as the star. The via and the en route transition. Approach vias are the various possible trajectories defined between the last point of the star and the first point of the approach. The revision at the from waypoint, PPOS, allows the pilot to define a lateral offset to the left or the right of the active flight plan. The offset value inserted is in nautical miles. Once the offset has been inserted, the initial flight plan appears as a dotted line. A lateral revision at a waypoint allows the pilot to insert into the active flight plan up to 5 segments of airways starting at the revised waypoint. The Airways page is accessed by the line select key 5 right on the waypoint lateral revision page. The revision is done for each segment by first inserting its airway identification and then by inserting its ending point. After the insertion in the flight plan is completed, some cleaning may be required. A holding pattern can be inserted from a revised waypoint. Using a database hold at, the parameters of the holding pattern are stored in the navigation database. Using a computed hold at, the parameters of the holding pattern are defaulted to predetermined values which can be modified. Once a holding pattern is inserted in the flight plan, it is initially not taken into account by the FMGC for prediction computation, as the system does not know if the pattern will be flown. Once entering the holding pattern, the system considers that only one pattern will be flown. Prior to entering the holding pattern, if managed speed is active and navigation mode engaged, the target speed will automatically be set to the computed holding speed. Or, if the speed is selected, a message, Set Hold Speed, will be displayed on the MCDU and PFD. The holding speed is the lowest of maximum endurance speed, ICAO limit holding speed, speed constraint, if any. The FMGC predicts the latest estimated time at which the aircraft must exit the holding pattern and the estimated amount of fuel so as to fly to destination according to fuel policy. Extra fuel equals 0. This revision allows the pilot to select an alternate airport. Several alternate airports may be stored in the database. The alternate page displays the track, distance and extra fuel corresponding to the different alternate airports. This assists the pilot in choosing the alternate airport according to weather conditions or fuel considerations. A lateral revision allows the pilot to initiate a diversion to the alternate by selecting the alternate flight plan from any revised waypoint belonging to the active flight plan. A flight plan discontinuity will be displayed between the revised waypoint and the first waypoint of the alternate flight plan. The vertical flight plan is defined by strategic data affecting the overall flight plan, tactical data affecting a given phase of flight, weather data. This data is either inserted by the crew or stored in the performance database. The strategic data is cruise flight level and temperature, tropopause, cost index, performance factor, trip wind, zero fuel weight CG, block fuel. The flight plan is divided into flight phases: pre-flight, takeoff, climb, cruise, descent, approach, go around, done. Each phase is characterized by its target speed profile: V2 plus 10, econ climb, cruise, descent speed, Mach, V approach. The speed profile is also called managed speed profile. The vertical flight plan includes vertical constraints assigned at waypoints, altitude and/or speed, which are stored in the database and entered manually by the crew. Another constraint, the requested time of arrival, or RTA, at the revised waypoint, may be entered by the crew. Also part of the vertical flight plan are constant Mach segments, defined by a desired Mach value and its associated starting point. The vertical flight plan also includes weather data inserted by the crew: temperature at flight level and destination, winds, climb, cruise, descent, approach. The FMGC optimizes the cost of operation computing econ speed, Mach, for each phase of flight. These speeds, Mach, are computed as a function of gross weight, GW, cost index, CI, cruise flight level, FL, winds, temperature models and actual ones, performance data. Econ speed or Mach. CI equals 0 corresponds to minimum fuel consumption or maxi range. CI equals 999 corresponds to minimum time. Additionally, the optimization function provides the following data: maneuvering speed for takeoff, approach and go-around, OSF, approach speed and VLS in landing configuration, optimum flight level and recommended max altitude. The optimum flight level is the one at which the aircraft incurs the lowest cost for given flight plan, GW and CI. Note, these terms will be discussed in more details in the performance course. Takeoff speeds V1, VR, V2, as well as the flex takeoff temperature or DRT takeoff level, are manually inserted by the crew in the MCDU. The FMGC computes predictions for the primary and secondary flight plan whenever the lateral vertical flight plan are completed and when all strategical and tactical data is inserted. These predictions comprise top of climb, TC, and top of descent, TD, fuel, speed change, etc. Predictions are provided on ND in the form of symbols in the current active autopilot modes. If navigation mode is active, they are displayed along the active flight plan. If heading track mode is active, they are displayed along the track line. Decel point. Altitude constraint, amber if predicted, missed, white if disregarded. Speed change. Interception point of the descent profile. Top of climb level off. Top of descent start of climb. The PFD provides the guidance targets on each dedicated scale. Speed target, vertical deviation, altitude target, heading or track target. Rules regarding FM navigation and flight planning. Rule 1. Cross-check the FM navigation accuracy. The FM position accuracy is essential for the proper functioning and validity of all FMS functions. Thus, cross-check FM position accuracy periodically except when GPS is primary. Cross-check it whenever GPS primary lost or nav occur downgrade messages come up on ND. Cross-check it whenever a doubt arises on the validity of the FM position. Principle: compare the bearing distance computed by the FM to a beacon with the bearing distance provided by raw data. Rule 2. Ensure proper sequencing of the flight plan, thus monitor the to waypoint. In navigation mode, a to waypoint is sequenced when it is overflown. In heading mode, if the cross track is large, the flight plan sequencing does not occur, which ruins the FM predictions. Principle: more specifically in heading mode, monitor the to waypoint and clear the undesired to waypoints, here LACU. Rule 3. Keep a flight plan discontinuity only when desired, for example when a radar vectoring is expected. Rule 4. Anticipate your actions on the MCDU. Fly ahead of the aircraft. Whenever useful information is known, ATIS on ground, an alternative clearance is expected, or a circling is planned, insert it in the MCDU as soon as time allows it. Rules regarding predictions. Rule 1. For predictions on time, speed, altitude and fuel, the FMS assumes that the aircraft flies along the flight plan in managed navigation and managed climb or descent modes. If selected heading track, open climb or vertical speed modes are used, the FMS assumes an immediate return toward the flight plan according a realistic trajectory. Note: VDEV on the prog page follows the same assumption. Rule 2. Use of vertical deviation. The vertical deviation is provided in descent as a round symbol, yo-yo, and along a VDEV scale in approach, brick, where one dot represents 100 feet. It represents the vertical deviation between the current altitude and the computed descent or approach path. Rule regarding the guidance. Rule 1. Managed modes availability. The managed modes of the FG guide the aircraft along the FMS lateral and vertical flight plan. The speed target may be either managed, computed by the FMS, or selected by the pilot on the FCU. Climb and descent modes correspond to a managed trajectory and cannot be engaged in heading or track mode. Two. Re-engagement of navigation mode. Navigation mode may be armed at any time when heading or track mode is used for flight plan interception. The interception can occur only if the track crosses the active leg before the 2 waypoint. When the track line does not cross the active leg, the interception will not occur. Rules regarding the displays. Rule 1. ND displayed mode selection. The ND arc and rose navigation modes may be used without any restriction if GPS is primary or FM navigation accuracy check is positive. If the FM accuracy check is negative, raw data has to be displayed on the ND. Rule 2. FMS monitoring in managed modes. When navigation mode is used, monitor PFD FMA for mode status, armed or engaged, and monitor ND for the expected trajectory and cross-track. When climb or descent modes are used, monitor target altitude and target speed, monitor VDEV in descent and location of pseudo waypoints on ND. The autopilot, AP, flight director, FD, and auto thrust, ATHR, are all integrated within the flight guidance, FG. They operate in various modes so as to guide the aircraft to associated targets such as speed, heading, glide slope, or FMS lateral flight plan. An FG mode and its associated target are managed when the FG guides the aircraft along the flight plan or when the aircraft flies a speed profile computed by the FMGS. In this example, navigation mode is the managed lateral mode, which allows the FG to guide the aircraft along the lateral flight plan. Climb mode is the managed vertical mode, which guides the aircraft along the vertical flight plan. An FG mode and its associated target are selected when the FG guides the aircraft to a target selected by the pilot on the FCU. In this example, heading mode is the selected lateral mode and open descent is the selected vertical mode. The pilot can engage selected modes by pulling the corresponding selection knobs on the FCU. The pilot can engage the managed modes by pushing the appropriate selection knobs on the FCU. When selected by the pilot on the FCU, the speed target is used by the autopilot flight director or autothrust as a constant target and is indicated in blue on the PFD. When managed by the FMS, the speed target is automatically adjusted by the FMS according to the speed profile computed. The speed target is indicated in magenta on the PFD. The autopilot flight director and autothrust are integrated, which means that there is an interaction between autopilot flight director vertical modes and autothrust modes. When the autopilot flight director pitch or vertical mode controls a vertical trajectory, the autothrust controls the speed or Mach. Note, if both autopilot flight director are off, the autothrust controls the speed. Autopilot flight director controls a vertical trajectory. Vertical speed or flight path angle, alt or alt star, descent on geometric segment, glide slope or glide slope star, final approach. Autothrust is in speed or Mach mode. When the autopilot flight director pitch or vertical mode controls a speed or Mach target, the autothrust controls a fixed thrust level. Autopilot flight director controls a speed target by adjusting the aircraft pitch in open climb or climb, open descent, take off and go around in SRS, Speed Reference System. Autothrust is in thrust mode. As a general rule, the FG guides the aircraft along the flight plan when managed modes are engaged, along the primary lateral flight plan in navigation mode, along the primary vertical flight plan in climb-descent modes. The aircraft will climb or descend, satisfying all altitude and speed constraints. The constraints defined in the vertical flight plan are associated to the lateral flight plan. If the pilot elects to fly away from the lateral flight plan in heading or track modes, the climb or descent modes are no longer available, reversion modes, and the constraints are disregarded. Navigation mode is the lateral managed mode, which guides the aircraft on the active leg defined by the from and the to waypoints. The navigation mode engages automatically after takeoff. It may be armed or engaged at any time in flight by pushing the heading knob on the FCU. When navigation is engaged, the lateral flight plan is displayed as a green solid line on ND. When flying away from the lateral flight plan, heading mode, the pilot can resume the normal navigation by pushing the heading selector, arming navigation. Condition: the track line must intercept the active leg. If the pilot arms navigation, navigation is displayed in blue on the FMA. An intercept point is computed and the flight plan display changes from dotted line to green solid line. In order to follow a vertical profile, the pilot can pull the altitude selector knob to engage Open Climb, Open Descent selected modes. Push the Altitude Selector knob to engage Climb, Descent managed modes. Select a target vertical speed or flight path angle by pulling the vertical speed knob. The Open Climb mode is a selected mode. It uses the Autopilot Flight Director pitch mode to maintain a speed Mach, managed or selected, while the autothrust maintains climb thrust. Open Climb is automatically engaged when the lateral flight plan is lost. The Climb mode of Autopilot Flight Director is a managed mode. It adjusts the pitch of the aircraft so as to climb towards a target altitude. This at a target speed with a fixed thrust level controlled by the autothrust in thrust mode. Climb is automatically engaged at acceleration altitude. In Climb mode, altitude constraints associated to waypoints will be taken into account. Constraints can be respected or missed. Altitude is always associated to Climb mode. Altitude is displayed in blue if no altitude constraint is associated. Altitude is displayed in magenta if an altitude constraint is associated to a waypoint. A magenta level off arrow indicates where the aircraft will reach the constraint altitude. A blue start of climb arrow indicates where the aircraft will resume climb once the waypoint is sequenced. The descent mode of the Autopilot Flight Director guides the aircraft along the FMS computed descent path so as to descend to the FCU selected altitude. The descent path includes several segments. From top of descent to first constraint waypoint, idle segment, several geometric segments computed up to reaching 1,000 feet with V-approach. Descent mode guides the aircraft along the pre-computed trajectory with speed target managed. A target speed range indicates to the pilot the acceptable speed variations required to track the descent path. A vertical deviation symbol is also displayed on the altitude scale, with digital value provided on the prog page. If the aircraft is above the flight path, the descent mode will command a pitch down to recover the FMS descent path. This symbol indicates where the descent path will be recovered, assuming that half speed brakes will be extended. If the aircraft is below the flight path, the descent mode will maintain the current speed or lower limit of the speed range until the descent path is recovered. Thrust might be added to recover the descent path. Descent mode respects the altitude, speed constraints when feasible. Altitude is armed in magenta, and target altitude is magenta if the FCU altitude is set lower than the constraint. If the altitude is set higher, then altitude and target altitude are displayed in blue. If heading or track mode is engaged, navigation managed is lost and the descent mode reverts to vertical speed or flight path angle mode. The aircraft continues its descent with the same vertical speed or flight path angle towards the FCU selected altitude, disregarding any altitude constraints. When the aircraft reaches cruise flight level, as set on prog page, the autopilot flight director goes into altitude cruise mode. The target Mach number is the Econ Cruise Mach number. If the aircraft is cleared by ATC at a level different from the one inserted on the prog page, altitude will be displayed on PFD. It is recommended to update the cruise flight level on the prog page to the new value for flight efficiency. The runway mode provides lateral guidance orders during takeoff, roll, and initial climb out, up to 30 feet, if a lock signal is available. Provided V2 is inserted in the perf page and slats are extended, the Speed Reference System, SRS, will engage automatically at power application, flex or toga. Speed Reference System is a vertical mode which controls the pitch and maintains the speed at V2 plus 10 knots as a minimum, or V2 in case of engine failure, up to acceleration altitude. Navigation engages automatically around 30 feet, provided a flight plan has been inserted with runway and SID. At thrust reduction altitude, lever climb flashes. The pilot must set the thrust levers in the climb detent. At acceleration altitude, the FG provides a pitch down in order to ease the acceleration towards the initial climb speed of 250 knots. Speed Reference System is replaced by climb mode. Precision approaches can be flown using selected modes, managed modes, where autopilot flight director provides guidance in lateral and vertical. The FMGC provides automatic guidance on the localizer and glide slope, provided ILS approach has been selected in the flight plan using the arrival lateral revision, or the ILS frequency and course have been inserted through the radio navigation page. The localizer can be intercepted in heading or in navigation mode. If the interception is completed in navigation mode, accuracy must be checked high, unless GPS is primary. Lock and glide slope can be armed using the approach mode push button, provided the ILS and radio altimeter are not faulty, the aircraft is above 400 feet, ILS frequency and course are set identically on both receivers. When the localizer is captured, lock star mode engages. Once the aircraft is established on the localizer axis, lock mode engages. The localizer is intercepted before the glide slope. When the glide slope is captured, glide slope star mode engages and switches to glide slope mode when the aircraft is established. As a general rule, glide slope star and glide slope will engage only if lock star or lock is engaged. Note: glide slope star and glide slope may engage before lock star for certain aircraft, if required by the airline. In case of ILS ground transmitter failure, autopilot flight director remains in lock glide slope modes. The localizer and glide slope deviations are lost and the flight director bars flash. In case of dual receiver failure, lock and glide slope reverts to heading vertical speed. The APs trip off and the ILS scales are removed. In this case, interrupt the approach unless you have the runway in sight. Land mode engages automatically when the aircraft is below 400 feet and lock and glide slope are engaged. The input on the FCU are then no longer taken into account by the FG. Land mode can only be disengaged by a go-around. At 40 feet RA, the flare mode engages. At 30 feet, if the autopilot is engaged, autopilot flight director guides the aircraft on the runway center line and provides the required pitch attitude for the flare. If autothrust is active, thrust reduction is activated and a retard call-out is activated at 10 feet. An auto-land red warning will be triggered below 200 feet radio altimeter if both APs trip off, or excessive deviations in lock above 15 feet or glide slope above 100 feet occur, or the lock signal is lost above 15 feet or glide slope above 100 feet, or a difference between both radio altimeter indications occurs. Non-precision approaches can be flown using selected modes, managed modes where autopilot flight director provides guidance in lateral and vertical. The use of track flight path angle is highly recommended. The managed mode can be used if the approach is defined in the database. Type of approach must be inserted in the flight plan and nav aids with associated course must be tuned manually through the radio navigation page. Navigation accuracy must be cross-checked using raw data information versus the FMS position unless GPS primary is displayed. If navigation accuracy is cross-checked low, the approach must be flown using selected modes, heading vertical speed or track flight path angle. Pushing the approach push button on the FCU will arm the lateral mode. Approach navigation and final are displayed in blue on the FMA. If navigation mode was already engaged, approach navigation engages immediately. If the interception is completed using heading or track modes, the track line must intercept the active leg. Approach navigation will engage when the intercept conditions are met. Note: do not forget to clear all remaining waypoints which do not belong to the approach. The final approach engages when the aircraft intercepts the descent profile. The final guides the aircraft on the profile down to MDA or MDH. A VDEV symbol shows the deviation from the pre-planned descent path. The final approach disengages if heading vertical speed or track flight path angle modes are engaged, or if the pilot pushes the lock push button. The final approach mode disengages and the autopilot disconnects when reaching MDA minus 50 feet or 400 feet above ground level if MDA was not entered. Raw data information using VOR, ADF needles must be displayed to cross-check lateral deviation. Revert to heading track in case of excessive deviation. If during approach GPS primary is lost, a triple click oral warning is triggered, and so you must cross-check your navigation accuracy.